So now we're going to look at cosine. And what's nice is that the cosine function is also 2 pi periodic. So to graph it, the process, just like we did for sine, will carry over here. In other words, it's really enough to look at what's happening on any interval of length 2 pi. In this case, we're going to look on the interval here. But since it's 2 pi periodic, it doesn't matter what interval of length 2 pi we're going to work on. These values here of cosine, you can derive them just from the definition of cosine. You know, you just go back to the unit circle definition. Here again, x represents an angle in radians. Okay, so let's actually graph cosine now. Okay, so just like before, right, we're going to have our x and our y-axis, like so. Okay, good. So we have 0, pi over 2, there's pi, 3 pi over 2, here's 2 pi. Now the x is there, so let me just move that out of the way just to make it look a little bit nicer. Okay, so now to graph cosine, again, we just plot the points. So at 0, we get 1. Pi over 2, we get 0. Pi, we get -1. 3 pi over 2, we get 0. And 2 pi, we get 1. Let me just fix that. So now we connect the dots. We're going to have this, like so. So the graph of cosine is going to look like this. And again, it's 2 pi periodic. So we can extend the graph of cosine to the whole real line by just continuing the cycle. In other words, the cycle is going to repeat, just like what happened with sine of x. Okay? So just like what happened with sine, we can sketch the graph. We extend it in both directions to get the graph of cosine over the whole real line. So if we wanted to graph it over the whole real line, we just keep on drawing the cycles. So for instance, to the left of the y-axis, for negative x, the graph is going to look something like this. And the process keeps on going. Again, it's 2 pi periodic, so you would use that to actually get the x values. For instance, it turns out over here, this is actually negative pi over 2. This turns out to be negative pi. And this is negative 3 pi over 2, and so on. You could derive these also from the definition over the unit circle as well. You could also do that. But that's basically the idea here. And these are just some very nice properties of cosine. As we have said before, cosine is defined for all real numbers. Okay, again, there you would just use the fact that it's 2 pi periodic. So the domain is all real numbers. Just like sine, the function turns out to be, the range that is between -1 and 1. I mean, that follows easily from the definition. It's also even, actually, cosine. We actually have seen that before. We have seen that if you do cosine of negative x, I mean, I might have called x theta. That is, instead of x, I might have had theta here, but it's really the same idea. But it turns out you end up getting this. So we end up getting this. So cosine is actually even. The graph, in other words, is symmetric about the y-axis. And again, the function is periodic with period 2 pi. Okay, so we could also list where the maximum of 1 and the minimum of -1, where they occur. I mean, basically what you do is you just see what's happening in the interval from 0 to 2 pi, and then you just keep on adding and subtracting 2 pi itself, 2 pi, excuse me, because again, it's 2 pi periodic. So for instance, Here at pi, we get a minimum of -1, right? Okay, so where else does the minimum occur? We can add 2 pi here to get 3 pi. So 3 pi is another place where we get a minimum. If we subtracted over here, we would have negative pi, and that's another place where the minimum occurs. So essentially, you just keep on adding and subtracting 2 pi. And then, if we wanted to graph a times the cosine of omega x, it's the same idea as what we saw earlier. For the capital A, right, you're just going to multiply the output by capital A, whatever A is. A, you know, is going to be non-zero. And if you have omega here, where omega is non-zero, right? Although really we can assume omega is positive, because if it was negative, since cosine is even, the negative would, in a sense, go away. But it's really the same exact approach as with sine. So for instance, let's say we wanted to graph y equals 2 times the cosine of x. Well, again, all we're going to do is take the output from cosine itself. We're going to multiply it by 2. So just to make it a little bit easier, let me do this. So we'll make the last column here 2 times cosine of x. And this one will make it equal to just cosine. So at 0 we get 1, pi over 2 we get 0, pi we get -1, 3 pi over 2 we get 0, 2 pi we get 1. So for 2 times cosine, here what we do is we multiply by 2. So at 0 we get 2, at pi over 2 we still get 0, at pi we get -2, 3 pi over 2 we get 0, and at 2 pi we get 2. So if we were to graph 2 times cosine of x, it would still be 2 pi periodic because we haven't done anything to x here. The only difference is that the graph is going to be vertically stretched 2 units. So at the height, so that the maximum is 2 and the minimum is -2. In fact, for fun, let's actually graph this. So instead of 1, we're going to have 2 here. Here's negative. Actually, let me draw it over here. So we have 0. Here's pi over 2. Here's pi. Here's 3 pi over 2. And here's 2 pi. So at 0, we're not going to get 1. We're going to get 2. Pi over 2, we still get 0. Pi, we get -2. 3 pi over 2, we get 0. 2 pi, we get 2. So let me just fix that. And now let's sketch it by connecting the dots. Like so. Okay? So that is what we're going to end up with. And this is vertically stretched. That is, it's the graph of cosine, but we're multiplying the outputs by 2. And now what if we have cosine of omega times x, where, as in the previous screen, omega was not 0? What do you do then? Well, we treat it just like the way we treated sine of omega times x. Basically, what we have is we're going to have 0 less than or equal to omega times x less than or equal to 2 pi, right? And so just like before, what we want is we want x in the middle. We want to know what x is doing. Okay, so how do we do that? We divide by omega. Keep in mind, omega is not 0. And really, we can assume omega is positive because cosine's even. So we're dividing by omega, right? So 0 over omega, that's just 0 itself. In the middle, we're going to get x. And on the right side, we're going to have 2 pi divided by omega. So as I wrote up here, the period is now going to be 2 pi divided by omega. A cycle is going to be completed in this interval from 0 to 2 pi over omega. And also, just like with sine, what you want to do is you divide by 4 to get the important x values. So you divide by 4 to figure out what x values on the x-axis you label when graphing it. Okay, so as a quick example, let's just do cosine of pi times x. So here we have omega is pi. Okay, so we have pi times x. Again, the idea is cosine of the input itself would normally make a full cycle between 0 and 2 pi. But we want to know what x is doing, right? We want x in the middle. So what do? We divide by pi. So we want to know, what does x have to do in order for cosine of pi times x to complete a full cycle? Well, on the left we get 0. In the middle we have x. On the right we have 2. So this tells us that the the period of cosine of pi x, so the period here is 2. And a cycle will be completed on the interval from 0 to 2. Now, if we wanted to graph it, we need certain x values, right? So basically what we're going to do is take the 2, divide it by 4. Let me just label this. Right, so we're going to start at 0. What we're going to do is divide by 4. So in other words, we're going to add 2 over 4, which is a half, to get a half. We add 2 over 4 again, which is again a half. We add that to get 1. Add it again to get 3 over 2. Almost there. Again, it's the same kind of process with sine. And then we have, again, 2 over 4 to get 2. We're going to get the value at each of these x's. Cosine of pi times x, well, that's cosine of 0, which is 1. Here we have cosine pi over 2, which is 0. Here we have cosine, oh wait, let me just fix that. Here we have cosine of pi times 1, which we know is -1. Here we have cosine of pi times 3 over 2. So that's cosine of 3 pi over 2, which is, again, 0. Let me just fix this. Let me just fix this up just to make it look nicer, like so. And then finally, we have cosine of pi times 2, and that's equal to 1. So these are the x values. So let's actually graph it. So if you remember, we had 0, we had 1 over 2, we had 1, we had 3 over 2, and then we had 2, 1, -1, and again, at 0 we got 1, at 0 we got 1, 1 over 2 we got 1, at 1 we got -1, 3 over 2 we got 0, 2 we got 1. Again, this is y equals cosine of pi times x, and we can see that one cycle of it is completed in the interval from 0 to 2. So we can see, just like we saw a few seconds ago, that the period is 2. One cycle of it is completed in the interval from 0 to 2,